the sum and difference rule. So here's the definition. If f and j are two differentiable functions at x in terms of x, then the sum rule, first, d over dx of the function f of x plus g of x is equals to d over dx of f of x plus the derivative of the second function g of x. So, meanwhile, for the difference rule, so d over dx of f of x minus g of x is the difference of each of the derivative of each of the function f of x minus g of x. Right? So yes. So now let's proceed to the following example to further understand the sum and difference rule. So find the derivative of each function. So first, let's start with f of x is equals to 9x plus 2. So here's the solution. So first, our f prime x derivative of the given function above is d over dx. So find the derivative of each of the given functions. So derivative of, start with 9x plus the derivative d over dx of constant 2. So simplifying further, that's derivative for this 9x, that's 9 times d over dx of identity function x plus the derivative of constant 2, right? Yes, so simplifying further, that's 9 times again the derivative of identity function x, that's always equal to 1. So 9 times 1 plus the derivative of constant is 0. So 9 times 1 plus 0, that's 9. So this one is now the derivative of the given function. Now, so next, let's proceed to the derivative of g of x is equals to 2x cubed plus 4x squared minus 3x plus 1. So first, so our g prime x here is equal to d over dx of the function 2x or expression 2x raised to 3 plus d over dx of 4x squared minus d over dx of 3x plus d over dx of constant 1. So simplifying further, so that's factor out this one first, factor out 2 times the derivative of x cubed, right? Yes, x cubed plus factor out first constant 4 times the d over dx of x squared, right? Yes. So minus factor out constant still 3 times d over dx of identity function x plus derivative of constant is 0. So simplifying further, so that's 2 times the derivative of x cubed, that's 3x squared, right? Yes, plus 4 times derivative of 2x, that's 2, or rather x squared, that's 2x, minus 3 identity derivative of identity function x, that's 1 plus 0. So simplifying further, that's 6x squared plus 8x minus 3. So our g prime x is this one. So any question? There's none. So now let's proceed to example C. Our h of x is equals to 4x squared minus 2 over 3 of 3x. So here's the solution. So again, first, since it's a complex, so we can say it's a complex rational function. So we're going to break down that one into a equivalent expression. So h of x is equal to 4x squared minus 2 over 3x, the original function, right? So we are going to break down that one into an equivalent expression. So it is also equal to 4x squared over 3x minus 2 over 3x. So simplifying further, so it's equal to 4x squared divided 3x, that's 4 third x minus 2 third x raised to negative 1, right? So thus we can now find the derivative easily. So our h prime x is equal to, so using this equivalent function expression, so it's equal to h prime x is equals to d over dx of 4/3 x minus d over dx of 2/3 x raised to -1. So now our h prime x here is equal to, factor out constant 4/3 first times d over dx of identity function x minus, factor out 2/3 first times d over dx of x raised to -1. So our h prime x is equals to 4/3, simplifying further, times this one, identity function, that's 1, minus 2/3. So this one is a power rule, apply power rule, that's negative x raised to -2, right? Yes, so our h prime x here is equals to, simplifying further, that's 4/3 minus 2/3 times -1 over x squared. Right? Yes, so now our h prime x, so through simplification further, is equal to 4/3 plus 2 over 3x squared. So this now is the final answer.